Well, hello guys and welcome back to Mr. G Physics. This time we're going to be answering question 2 from this work energy and power consolidation material, and this is the question 2 from the self-assessment challenge test. You'll see that once you finish all this question of the material, this should not be that challenge anymore. Anyway, the question says a steel ball of mass 0.7 kilograms. The mass of this steel ball is equal to 0.7 kilogram is suspended from a light string. The steel ball is released from rest, and at point A it moves at 3 meters per second. So note, at point A is not at rest. The speed at point A is equal to 3 meters per second. Okay, point A is 20 centimeters above the lowest point of swing, point B. So it's 20 centimeters. You can see it there from the lowest point B. Remember, you cannot work in centimeters, so you can convert this one. This one will be equal to 0.2 meters. We're going to convert right here. All right, now calculate the mechanical energy of the ball at point A. All right, now mechanical energy, guys, remember, is the addition of kinetic energy plus potential energy. I think this one is quite simple. So we can answer that question here. Mechanical energy at point A is equal to the addition of the kinetic energy at point A plus the potential energy at point A. You must also remember that kinetic energy is half the product of mass, speed square, and the potential energy is equal to the product of mass, acceleration due to gravity multiplied by the height. So if we go back here, the mechanical energy at A is equal to the addition of half mass speed at A square plus mass acceleration due to gravity height at A. Alright, so we can substitute everything. Everything is given to us. And then we get that the mechanical energy at A will be equal to 4.522 joules. That is the mechanical energy at point A. Okay, so if you do this one, you already will get 4 marks, and it's quite simple to get those marks. So 1 for the formula, there we go, 1 for the substitution of the kinetic energy, 1 for the substitution of the potential energy, 1 for the final answer. There are the 4 marks here. Question 2.2. At point A, the ball enters a liquid, and as a result, it starts moving when it releases point C, which is 20 centimeters above point B. Sorry, 12 centimeters above point B. So this is a liquid. As you can see there in the picture, it looks like a liquid. And then, obvious, there is resistance from the liquid on that sphere. Okay, and the sphere, as a result, won't go to the same height. It will stop before. In that case, it will stop when it is at 12 centimeters from point B. So we can add here that the speed at C is equal to 0. That one, we know it. And this one is 0.12 meters. That is also a conversion there. Remember, we're working with meters. Now, question 2.2.1, calculate the work done by the resistive force of the liquid in bringing the ball to rest. So what we need to know, that resistive force is a non-conservative force. Therefore, we can actually use the law of conservation of energy, which is what we are going to do real fast. And for this one, we're going to do it in a new page. So we come here. This one is question 2.2.1. So we're going to use the law of conservation of energy. And this question is a little bit tricky. It's not just like that. So let's write here the law of conservation of energy. The work done by the non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Okay? We're starting from there. Now, here is where the trick starts. The change in kinetic energy plus the change in potential energy could be called change in mechanical energy, because kinetic plus potential is mechanical energy. Okay, so change plus change will be the change in mechanical energy. All right, so we can say now that the work done by the non-conservative forces is equal to the change in mechanical energy. Okay, now change in mechanical energy can also be, like all the changes in physics, this one could be change in mechanical energy, final mechanical energy minus initial mechanical energy. Okay, that could also be for instance, we have the mechanical energy at A, so this one could be the mechanical energy at C, and this one could be the mechanical energy at A. All right, so we can see here that the work done by the non-conservative forces is equal to mechanical energy at C minus the mechanical energy at A. Mechanical energy at A, we already know it. We calculated previously, right? Mechanical energy at C will be the addition of kinetic plus potential. So we come here, we have that the work done by the non-conservative forces is equal to half mass speed of the ball at C square, okay, plus mass acceleration due to gravity height at C. We are working with the mechanical energy at C. All right, this one is the mechanical energy at C. All that on the node square, all that one there is the mechanical energy at C. All right, and this minus the mechanical energy at A, which we already calculated, so we don't have to recalculate it. There it is, mechanical energy at A. And guys, this is the question. It's not that complicated. It's tricky because you need to change a little bit what we used to do. Calculate the work done by the resistive force, which is this work done. Okay, this is what we are looking for, and then the rest is just substituting. Let's do it real fast. Work done by the non-conservative force, which is the resistive force in this case, is equal to, and then we just substitute the values we have here. Okay, so this one is half 0.70 because the ball stop at C, plus here is 0.7. Let's fix that better. 0.7 multiplied by 9.8 multiplied by 0.12. All right, all this one minus what we got for mechanical energy at A, which was 4.522 minus 4.522. And this is what you are going to get for the work done by the non-conservative forces. We get that the answer is minus 3.6988. You can round off to 2 decimal places if you want here. Okay, so if you round off, this one will be equal to minus 3.7 because you cannot round off later or furthermore. So this one will be the answer for this question, which is not that bad. It seems bad, but it's really not that bad. So let's mark this question. Let's mark this question. One mark here will be for the using the law of conservation of energy, which is starting point, is the one for this substitution here, and one for this one, and then the final answer there. This is what we are looking for. Guys, I hope it's clear. It's not that bad. Let's continue with this question. There's only one more. What is the work done by the tension force? Explain your answer. And that is a good question. Well, guys, if we go to the picture quickly, the tension force every time is going to be perpendicular to the displacement. And then let's look. Tension force every time is in this direction. This one is tension there. When it's at B, tension is pointing there. When it's at C, tension is pointing there. And now you say, but Mr. Gomez, the angle is not the same. Well, it's not the same as it moving. But at every time, at every point you stop, the displacement, for instance, when it's at A, the displacement is going in that direction. All right, so this one will be the displacement. The angle is 90 degrees. When it's here, the object is actually moving in that direction. That will be the displacement here. So this one is 90 degrees, and so on. When this one moved there, the displacement was in that direction, and then the angle was, in that case it's 0, but it was supposed to go moving in that direction. So let's take off that side there. So you can see that the angle every time is going to be 90 degrees to the displacement. So the answer for that question is going to be 0. This one is for question 2.3. Is going to be 0. Why? The angle is equal to 90 degrees, that is theta, and the cosine of 90 degrees is equal to 0. This is the explanation. That you have to do it in Word, guys. And there are 3 marks: 1 for saying 0, 1 for saying the angle is 90, 1 for saying cosine of 90 is 0. And this is the end of this first challenge question of the self-assessment. Thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. Jeep here.